Okay, so here they are, all together. So 0.75, 1,
2.
That's 1.5.
1.5,
2.
2,
2.5.
2.5, and
4.
4. So tell me, now that you see them all together, what do you think?
Well, they seem to be getting like larger in general volume because this one is kind of small. And it just gets bigger.
Oh, I just noticed
Yeah.
something from looking at their shadows.
Oh, okay, looking at their shadows.
So, I'm looking at 2 and 4.
Uh-huh.
They look similar. Like 2's shadow, just the way the lighting is, you've got a rectangle,
Oh, interesting.
and then 4, you're sort of getting a rectangle. You can sort of see how it transforms.
Yeah. Well, so let's talk about both of those things.
Right.
So the first thing you said was they seem to be getting bigger in volume, and that would be measured in our normal way of thinking about volume.
But
Yeah.
they're exactly the same volume in their respective metrics, I think.
Well, I don't know that that's true. Actually, I'm not sure. Our normal sphere, in our normal way of thinking about spheres, and then what's called the L2 metric, has a volume of 4/3 pi r cubed.
I mean, what would you have a volume formula for, say, like this octahedron?
Yeah. How would you have a volume formula, and what would it be, and would it involve pi?
Or the pi in here, in this.
Yeah. So, just like you can change how you measure distance, you can change how you measure volume, and you would hope it would be consistent
Yeah.
across them. So that it's not clear. Certainly, in 2 dimensions, pi was not the same. The circumference to the diameter was not the same.
Yeah.
I guess we'll just have to explore this a little more and see what the volume is. But our normal definition of volume seems to be that the volume would be increasing. What do you think happens when I go bigger than 4?
Well, maybe you get more cubical. Like,
More refined.
it looks like this.
Yeah, well, is that on? Yeah, more and
Snap
more.
cube.
More and more and more cubical. But at 4, it's already nearly a cube. In her pictures in the video, do you remember what it looked like with the squares? Or
It's
circles?
started looking more like a square.
Yeah, although I don't think it went this quickly.
At
I don't-
infinity, well, like it went more slowly. There.
Yeah, at infinity, we definitely would have a square or a cube. And now you said something about the shadows, which is really interesting.
Yeah, like it's weird the similarities between their
Oops,
shadows.
sorry.
Like if you didn't look at their shadows, these two shapes look totally different. But their shadows are actually really similar.
Yeah. Huh. Wow, that's a really neat thing to notice.
And then there's this and this have actually like almost the same shadow.
Yeah, the 1.5 and 4.
Maybe these are like since the octahedron and cube are duals of each other, maybe that has to do with shadows somehow.
Yeah, it could be. It could be. Yeah, and the octahedron is 1, and the cube would be infinity.
Yep.
Huh. Cool.
Yeah.
Yep.
Well, this is a really neat project, and it shows a really interesting area of math. And the one idea that you can take away from this is that there are different ways to measure distance,
Cool.
and there are different ways to measure volume. And when you do measure volume in certain ways, you get different shapes.
Yeah.
So cool. Good job, guys. This is a really fun 3D printing project.